Hi everyone. In this video, we are going to implement binary search algorithm using recursion. So we have already implemented binary search using iterative mode in which we traverse through the array and every time we do compare the middle element with the given target element and we are going to reduce the search space. The same thing, this part is exactly same, but how we will apply recursion algorithm, we will see. So you know that binary search uses divide and conquer approach, right? So in divide and conquer approach, the given problem is divided into sub problems and we will recursively solve the sub problems. So but in binary search, we are going to solve only one sub problem and other sub problem we are going to ignore completely. So for example, this is the input array is given. Low index as 0 and high index as 10. And to apply binary search algorithm, array should be in sorted nature. So here we are given that array is in sorted order. So in binary search approach, what we do? We compute mid index first and we do compare the element at mid index with given target element. So in this case, low equal to 0 and high equal to 10. So let's write low equal to 0, high equal to 10. That means mid equal to 0 plus 10 divided by 2, which is 5. Then we do compare a mid with target. So a mid here is 8 and target is 17. So what is the relationship? 8 less than 17, right? So what we did, we exactly divided the given search space into two parts, right? So at middle index. So this is one search space and this is another search space. But when we come to this kind of equation, we are sure that the given target element for sure won't exist in this search space because the elements are in sorted order. So this is the only difference, that we are not going to solve both the sub problems, rather we ignore completely half of the search space in case of binary search. Now what are the values of low, high and mid? So low will be updated to mid plus 1, which is 6, and high is as it is, and then mid will be 6 plus 10 divided by 2, which is 8. Then we are going to compare a mid with target again. 21 is greater than 17, right? So based on this, what we can decide? Target 17 won't exist from this point to this point because the elements after 21 is obviously greater than 21, and so we won't get our target element into this particular part. We have divided the given array at this point and only we are going to ignore this space, and then this is the only space we left. So like this we do continue our search process. Let's convert the same thing into the code using recursive approach. So here I have defined class name as binary search recursive because already I have another class which is binary search, which I have written for iterative mode. So first let's define the method. So the method signature will be public int search, and what is the search space here? Array, and we are going to get the target element, which we have to find whether this target element is present in the given array or not. Here one assumption is that the given array is already sorted. So initially our search space is from index 0 to 10, right? So based on the middle index value, we are going to reduce the search space. How we are doing it? By changing either low or high index value. So that means we need to have two more parameters which are going to use it, that is low and high. So first let's create a recursive relation private method which usually takes int array and int target, and here we are going to define what is the search space. Here we are defining in terms of low and high index. So int low and int high. So this is the recursive relation which we are going to use it. So here first initially what is our search space? Return array and target and initially low is at 0 and high is at array dot length minus 1, right? So because array is having 11 elements, so high index will be at 10. So array dot length minus 1. So first what we have done, we have computed mid index. So int mid equal to low plus high divided by 2. Then we have compared a mid with target element. First case is if a mid, here I am taking array A. If a mid equal to target, this case we found that the given target element is present in the given array. So we have to return the index mid. So if this is not the case, there are two more possibilities, which are either a mid less than target or a mid greater than target. Let's see one by one. We got 8 less than 17. So the target element is greater than the middle element in the array. So if a mid less than target, so this case we are going to ignore completely first half of the array. So here we have split the array. So at this point we have split the array, and instead of solving two sub problems, we are completely ignoring this subarray and only we are using this particular subarray. So then recursively we have to call, means what we will do, return search a comma target, and then we have to tell now what are the low and high index of this particular search space. So here low will be mid plus 1 and high will be as it is. There is no change. So low will become mid plus 1 and high there is no change. Suppose if this is not the case, means return search a comma target. Let's take target element as 2. So what is a mid value? 8, right? 8 greater than 2. So if 8 greater than 2 means after 8, for sure we won't get our target element, which is 2. So this particular case we are going to ignore from mid to high and we are going to search only in the first half of the array. So that means low will be as it is and the high value will become mid minus 1. If you notice it, we are calling the same function again and again just by dividing the given array, and we are ignoring half of the search space every time just by changing either low or high values. The recursive algorithm should have the base case. So what is the base case here? So we know that always low less than or equal to high. At any time if low is crossing high, means we have exhausted our array and we didn't find the target element in the given array. So if low greater than high at any time, we are going to return invalid index. So just if you compare iterative algorithm, whatever we are doing these steps, instead of updating high and low, we are calling the same method again and again by updating low and high values. So instead of this iterative low, we just converted into the base case, because for recursive algorithm, base case is must and should. Otherwise, without having this, we may end up with infinite loop also. So for that, let's take a negative use case in which given target element is not present in the given array. Assume that here target element is 6, which we have to find out whether element 6 is present in the given array or not. So first initially low will be 0, high will be 10 and mid is 5. 8 and 6, what is the relation? 8 greater than 6. So this means, so 8 greater than 6 means, this means we are into this condition. So in this case, low will be as it is and high has to be updated to mid minus 1. 4 and low will be as it is. Now, so the search space is going to become only from low to mid minus 1. So remaining array we are going to ignore. So in this, what is the middle index? So 0 plus 4 divided by 2, which is 2. What is the value at index 2? 3. And relationship between 3 and 6 is 3 less than 6. So second time what we got? 3 less than 6 means it is matching with this particular condition. So we are going to execute this line, right? So this case, So we are going to ignore this and we are going to update our low value to mid plus 1. So here mid plus 1 is 3 and high equal to 4. So 3 plus 4 divided by 2, which is 3. So now the search space is only 3 and 4. Now what is the element at third index, which is 5, and target is 6. What is the relation? Again 5 less than 6, right? So that means again we have to update our low index to mid plus 1. So mid plus 1 is 4 and high is as it is, which is 4, and the middle index is going to be 4 because 4 plus 4 divided by 2, which is 4. So now what is the element at fourth index, which is 7? And the relationship between 7 and 6 is 7 greater than 6. As a mid greater than target, we are going to execute again this line, right? So means we have to update high value to mid minus 1. So low will be as it is and high will be mid minus 1, which is 3. So if you notice it, low index is greater than high index. So that means we have exhausted our array and we didn't find the target element in the given search space. So here we are going to exit. So another way what you can think of is, so whenever we get this kind of situation when both low and high are equal, means only one element present in the array. So that element is 7 in this case. So 7 and 6, either it can be equal or not equal, right? So this case it is not equal. So that means we are going to say that it is not matching, means return simply -1. So here itself we can stop the program by checking these two conditions, or we can proceed one more step just by checking whether low is crossing high or not. So here I am writing base case as if low greater than high, we are going to return invalid index, which is -1. And let's run the code. So what is the expectation here? The target element is present at index 6, right? So 17 exists at index 6. So now let's take another one which does not exist in the array. So we have taken 6, right? So let's run the same code for target element 6. So I hope the code is clear to you. So thank you for watching. Stay tuned and happy learning.